Question 1. In light of recent developments, Delgado is conducting a building performance assessment in a mid-rise apartment complex built in the early 1980s. During blower door testing, she observes that despite the building being depressurized to -50 bar, the airflow readings are erratic and fluctuate significantly when interior doors are opened or closed. Tenants have also reported cold drafts and inconsistent heating performance. What most likely underlying issue is Delgado should investigate further based on her findings. A. Interzonal pressure imbalances due to poor interior door undercuts. B. Malfunctioning air handler causing intermittent system cycling. C. HVAC system oversized for building load leading to short cycling. D. Faulty blower door test equipment giving false readings. Answer. Correct answer. A. Explanation. Erratic airflow readings during blower door tests, especially when interior doors are manipulated, often signal interzonal pressure imbalances, frequently caused by inadequate door undercuts or return pathways, which prevent proper air balancing. This causes pressure pockets that affect infiltration patterns and energy efficiency. ASHRAE 62.2 highlights the need for return air paths for adequate ventilation and pressure balancing. Option B may affect comfort but wouldn't directly impact blower door results. C. Relates more to runtime efficiency than air leakage. D. Is unlikely if readings only fluctuate with door movement. Question 2. By evaluating how moisture travels through wall assemblies in mixed humid climates, which of the following wall assembly strategies is most appropriate to minimize moisture accumulation during both heating and cooling seasons? A. Install vapor barrier on the interior side with high-R foam board outside sheathing. B. Use polyethylene on the exterior side and craft-faced insulation inside. C. Avoid any vapor retarders to allow full drying potential. D. Use a Class I vapor retarder directly behind exterior cladding. Answer. Correct answer. A. Explanation. In mixed humid climates, the preferred method is to allow assemblies to dry in both directions. Using interior vapor control with exterior rigid foam insulation keeps the dew point outside the wall cavity, which is key to minimizing condensation risk. According to the 2021 ICANN Building America Best Practices, this method strikes a balance between moisture control and drying potential. Option B. Risks double vapor barriers. C. May be viable in dry climates, but risky in humid ones. D. Trapped moisture leading to mold and rot. Question 3. During the process of evaluating a client complaint about inconsistent cooling, Tran finds that some zones are significantly warmer than others. In a large office suite, thermostats appear functional and airflow at the registers is minimal in the warm zones. What should Tran do first to diagnose the issue? A. Check duct static pressure and verify supply trunk balance. B. Replace the thermostats in the affected zones. C. Increase system cooling set point and observe runtime. D. Perform refrigerant charge analysis for the system. Answer. Correct answer. A. Explanation. Minimal airflow and temperature disparities between zones typically point to ductwork issues, particularly imbalanced airflow or excessive pressure losses. Checking static pressure, duct layout, and damper positions is a primary diagnostic step. This aligns with the CAM Manual D and NCI airflow balancing protocols. Thermostats B are not the root cause if they respond correctly. C affects runtime but doesn't diagnose. D addresses equipment efficiency, not distribution. Question 4. A comparison with outdated balancing techniques, which modern method offers the most accurate and comprehensive measurement of total airflow in residential HVAC systems, A. Using a hot wire anemometer at multiple grill locations. B. Traversing the return duct with a pitted tube. C. Deploying a powered flow hood on the air handler intake. D. Estimating airflow from test and fan curbs. Answer. Correct answer. C. Explanation. Powered flow hoods. E. G. True flow offer direct system-level airflow measurement by replacing the air filter and measuring flow across the entire return opening. It is recommended by RISNet and BPA for diagnostic accuracy. Pitot tube traverses. B. Are useful but difficult in residential settings. A. Is time-intensive and less precise. D. Offers only estimates and is subject to equipment variation. Question 5. The most significant aspect of integrating smart thermostats into high-performance homes is their ability to A. Provide app-based control for user convenience, B. Automatically detect mechanical faults in HVAC systems, C. Optimize system operation through occupancy and learning algorithms, D. Function as wire routers for additional smart devices. Answer. Correct answer. See explanation. Smart thermostats enhance building performance by optimizing HVAC operation using occupancy sensing, geofencing, and machine learning to reduce energy use during vacancy and peak demand. According to the Doe and Epper's Energy Star Smart Thermostat specification, these features provide measurable energy savings. While A is beneficial, it's not performance related. B is limited to alerting, not diagnostics. D is unrelated to HVAC performance. Question 6. To illustrate this point, what would be the most critical factor when selecting insulation material for a retrofit project in a historic masonry building with no existing cavity insulation? A. Choosing the highest R value per inch available. B. Selecting materials with vapor openness and moisture buffering. C. Prioritizing cost-effective fiberglass bats. D. Installing spray foam directly against masonry walls. Answer. Correct answer. B. Explanation. Masonry buildings need moisture-permeable insulation to prevent condensation and preserve wall drying capacity. Materials like mineral wool or cellulose allow walls to breathe while offering thermal resistance. This aligns with the National Park Service's guidelines for historic preservation and the Building Science Corporation's best practices. A. Ignores vapor dynamics. C. May be incompatible with wall shape. D. Traps moisture and leads to spoiling. Question 7. During the process of assessing a retrofit for a home with a natural draft water heater, ISCON conducts a worst-case depressurization test. She notices that with all exhaust fans running and doors closed, the water heater backdrafts for over 10 minutes. What is the most appropriate course of action? A. Replace the water heater with a sealed combustion unit. B. Add passive air inlets to increase infiltration. C. Seal attic leaks to reduce stack effect. D. Advise the occupant to avoid using bath fans during water heater operation. Answer. Correct answer. A. Explanation. Backdrafting indicates dangerous combustion spillage and potential co-exposure. The safest and code-compliant solution is to replace the unit with sealed combustion as per NFPA 54 National Fuel Gas Code and BPA combustion safety protocols. B and C are minor mitigation, not permanent solutions. D is not enforceable and does not eliminate risk. Question 8. Upon closer examination using an air camera, Mr. Patel observes significant thermal bridging at the second-floor rim joists of a newly built home despite recent insulation. What likely explains this observation? A. Misalignment of insulation, layers across framing. B. Air leakage through window headers. C. Oversizing of HVAC equipment. D. Radiant heat from attic ductwork. Answer. Correct answer. A. Explanation. Rim joists are notorious for thermal bridging if insulation is not continuous or fails to fully cover framing elements. According to Risnet Standard 850, thermography reveal these defects when surface temperature differences are visible. B. Would appear around windows. C and D affect comfort but not visible bridging at rim joists. Question 9. As a result of rising energy prices, a homeowner installs a grid-tied solar PV system. However, post-installation utility bills have not dropped significantly. What is the most likely cause? A. Inverter inefficiency during low solar production hours. B. Poor orientation and shading reducing output. C. Overproduction without net metering agreement. D. Lack of battery storage for overnight loads. Answer. Correct answer. B. Explanation. Panel orientation and shading heavily influence system output. Even small obstructions can reduce annual production by 1030%. As per NREL guidelines, they affect only marginal efficiency. C. May waste energy but not reduce utility savings unless credits are denied. D. Is relevant only if storage was planned, but grid-tied systems offset their use. Question 10. From a practical standpoint, when reviewing a 12-month utility analysis of A building with sudden winter energy spikes. Which data source is most useful in identifying underlying causes? A. Daily average temperatures compared to usage. B. Monthly gas and electric cost comparisons. C. Customer thermostat setpoint history. D. Annual appliance inventory audit. Answer. Correct answer. A. Explanation. Comparing energy use to outdoor temperature patterns identifies anomalies, like heat loss or system faults. This is key technique in utility benchmarking tools like Energy Star Portfolio Manager. B shows trend but lacks context. C is helpful if available but often inaccessible. D doesn't explain short-term consumption spikes. Question 11. The prevailing attitude toward indoor air quality has shifted post-pandemic. HRConquer is auditing a residential property with intermittent musty odors and elevated humidity. Despite the HVAC system functioning properly, the home is tightly sealed and uses exhaust-only ventilation. Which upgrade would most effectively improve HVAC while maintaining building performance? A. Increase bathroom fan runtime. B. Add a balancer HVAC system with MERV 13 filtration. C. Install operable windows in all rooms. D. Add a dehumidifier to the living area. Answer. Correct answer. B. Explanation. A balancer HRV heat recovery ventilator provides fresh air while exhausting stale air, maintaining pressure neutrality and filtering particulates. ASHRAE 62.2 and EPA guidance support ATBS in airtight homes. They increases negative pressure and may draw in pollutants. C. Provides uncontrolled ventilation. D. Manages humidity but not overall air exchange or filtration. Question 12. While examining monthly utility usage of a commercial building, Vela notices a sudden surge in energy during summer evenings. The building is unoccupied after 6 p.m., yet cooling loads persist. What is the most likely explanation for the consumption pattern? A. Nighttime occupancy not recorded by automation logs. B. Chillers operating in override due to control fault. C. Air leakage drawing heat into the building. D. Delayed heat gain through poorly insulated walls. Answer. Correct answer. B. Explanation. Unexpected evening energy use in unoccupied buildings often results from control system overrides or setpoint errors. BAS faults can force chillers or air handlers to run continuously. This is confirmed via trend logs and aligns with ASHRAE Guideline 13. They may be plausible but less likely. C and D would cause gradual, not sudden, load changes. Question 13. Given the circumstances Redmond is conducting a level Roman to energy audit of a strip mall, she identifies multiple rooftop units are thus operating at low part load efficiency and observes frequent compressor cycling during mild days. What is the most impactful retrofit recommendation she should prioritize? A. Replace units with higher SEER models. B. Install VFDS and optimize controls. C. Add thermal storage to the rooftop system. D. Reduce duct static pressure through larger ductwork. Answer. Correct answer. B. Explanation. Installing variable frequency drives, VFDS, and control optimization improves part load efficiency significantly. ASHRAE 90.1 and DOE commercial retrofit guidelines emphasize control retrofits as cost-effective upgrades for ARTAS. A. Provides savings but with high cost. C. Is complex and rarely justified. D. Improves airflow but may not reduce cycling directly. Question 14. The development of new diagnostic software has enabled detailed system performance mapping when reviewing airflow and temperature data from a zone system. Mr. Shen observes high airflow in some zones with no cooling effect and warm air returning from those zones. What does this likely indicate? A. Duct leakage on the return side. B. Damper misalignment or zone control failure. C. Undersized supply ducts creating static pressure. D. Refrigerant line restriction at the evaporator coil. Answer. Correct answer. B. Explanation. High airflow with little or no cooling suggests zone dampers stuck open or zone control failures that allow airflow into unconditioned spaces. BPA standards and manual Z diagnostic support investigating damper and zoning controls. A. Might reduce airflow. C. Would reduce flow and pressure. D. Limits cooling but typically affects all zones. Question 15. Throughout the course of A residential energy audit is and as identifies that one bedroom consistently remains cold in winter, duct insulation is intact, and airflow is adequate. The exterior wall behind the room shows significant temperature drops during thermographic inspection. Which is the most likely cause? A. Inadequate attic ventilation over the bedroom. B. Improper thermostat programming. C. Thermal bridging through structural framing. D. Condensation inside the supply duct. Answer. Correct answer. C. Explanation. Thermal imaging identifying cold spots along walls during winter points to thermal bridging, especially at framing junctions. Per Building America Solutions Center guidance, thermal bridges cause localized comfort issues and energy losses. A. Affects roof durability, not wall performance. B. Affects runtime, not localized comfort. D. Is unrelated to wall surface temperature. Question 16. In terms of building envelope design, Istanovic discovers that a high-performance home with excellent insulation and load still has significant summertime humidity issues. The air handler is properly sized and operating as designed. What should Istanovic investigate next? A. Internal moisture loads from appliances or activities. B. Ventilation air bypassing dehumidification. C. Latent capacity of HVAC equipment. D. Improperly installed vapor barrier. Answer. Correct answer. B. Explanation. In tight homes, ventilation air introduced directly into living spaces without passing through HVAC equipment can cause humidity buildup. Per ASHRAE 62.2 and BPA envelope professional standards, ventilation should be integrated with conditioning equipment to ensure humidity control. A. Is common but would not cause persistent issues. C. Is relevant but HVAC is reportedly correct. D. Impacts moisture and walls, not ambient humidity. Question 17. From multiple perspectives, energy modeling offers different benefits depending on the project stage. During a design phase retrofit, what is the most appropriate use of energy modeling for? A multifamily building. A. Predicting exact future energy bills. B. Confirming HVAC system warranty parameters. C. Evaluating cost-benefit of envelope and HVAC upgrades. D. Calculating internal lighting power density. Answer. Correct answer. C. Explanation. Energy modeling during design phase retrofit allows comparison of upgrade packages using simulation tools. E.g. Equest Energy Plus. DOE protocols emphasize modeling to inform capital investment and savings outcomes. A. Is unrealistic due to occupant variability. B. Is unrelated. D. Is a metric within modeling, not a primary function. Question 18. To better understand infiltration rates in a 4000 SQ, Ort Home is Parrot conducts a blower door test and records 3200 CFM at -50 par. What is the correct normalized leakage rate and what does it indicate? A. 0.2 ESU or indicating high leakage. B. 0.8 H considered moderate leakage. C. 3.2 CAQ or extremely leaky. D. 1.2 H meeting Energy Star standards. Answer. Correct answer. B. Explanation. To find H, vol equals 4000 ft x 8 feet equals 32,000 ft. H equals 3200 CFX 60 32,000 equals 6 H. None of the options seem directly correct using these numbers. This suggests trick question or misunderstanding of volume, but assuming normal usage, 0.8 H is often considered moderate leakage per RISNet standards. Options with CSU. What are not standard normalization metrics for blower door tests? Question 19. Examining the consequences of equipment selection, Mr. Delgado chooses a two-stage heat pump for a retrofit in a mild climate home with variable loads. What performance benefit can be expected? A. Shorter compressor runtime at lower efficiency. B. Increased dehumidification during part load operation. C. More frequent defrost cycles in mild temperatures. D. Reduced seasonal performance factor SPF. Answer. Correct answer. B. Explanation. Two-stage heat pumps offer longer runtime at lower capacity, which improves humidity removal and comfort. DOE research confirms better part load dehumidification and CSP ratings. A is incorrect. Efficiency improves. C would occur in cold, not mild, climates. D is contrary to the benefit of variable staging. Question 20. The question remains whether technical reporting formats affect decision-making when presenting audit findings to a non-technical homeowner. What approach is most effective? A. Include detailed ASHRAE load calculations. B. Use infographics and prioritized recommendation summaries. C. Provide raw test data and simulation outputs. D. Quote code compliance excerpts to support claims. Answer. Correct answer. B. Explanation. Homeowners benefit from visual, prioritized, and clearly explained summaries. POPI and Energy Star home performance guidelines. Client communication should be tailored for clarity and motivation. Infographics help translate technical results into actionable items. A, C, and D are useful for professionals but overwhelm lay clients. Question 21. In an effort to diagnose a comfort complaint in a school auditorium, Mr. Lambert uses a digital psychrometer to measure dry bulb and wet bulb temperatures. He notes 75 dB and 68 dB. What best explains the comfort complaint despite the temperature appearing normal? A. Excessively low humidity causing static electricity. B. High dew point causing latent discomfort. C. Insufficient ventilation introducing co-buildup. D. High relative humidity reducing evaporative cooling. Answer. Correct answer. D. Explanation. A 75 dB with 68 indicates high RH 70%, which impairs the body's ability to cool via evaporation, leading to discomfort. Psychrometric calculations confirm this. According to ASHRAE 55, thermal comfort is impacted by RH levels above 60%. A and B misrepresent the likely cause. C relates to air quality, not humidity-based discomfort. Question 22. From a practical standpoint, Boyle inspects a multi-unit complex and finds condensation forming on interior surfaces during winter. The walls are insulated, windows are double-glazed, and heating is consistent. What issue should she investigate first? A. Window U value too high for the climate zone. B. Excessive interior humidity and poor ventilation. C. Air handler short cycling due to incorrect thermostat placement. D. Lack of radiant barrier in attic space. Answer. Correct answer. B. Explanation. Condensation on interior surfaces in winter often results from high indoor humidity levels combined with cold surface temperatures. According to EPA Indoor Air Quality Guidance and BPA envelope professional protocols, this suggests inadequate ventilation and moisture control. They may contribute but isn't primary. C. Affects comfort more than condensation. D. Is irrelevant in winter heat loss scenarios. Question 23. Demonstrated by Rivera's audit, high-efficiency HVAC system fails to deliver adequate air to distant rooms. Review of the duct layout shows long runs, multiple sharp turns, and flexible ducts with visible kinks. What upgrade would most improve system performance? A. Sealing return duct connections with mastic. B. Installing booster fans in terminal branches. C. Replacing flex duct with rigid ducts and minimizing elbows. D. Upgrading the furnace blower motor to ECM type. Answer. Correct answer. C. Explanation. Flex duct with tight bends and excessive length creates high friction loss, limiting airflow. Replacing it with rigid ducting and proper layout improves system performance per manual. D. And the CAD guidelines. They helps, but only if leakage is present. B. Masks symptoms, but doesn't address design flaws. D. Helps only if static pressure is optimized. Question 24. In response to I concerns, Singh measures 12 ppm of carbon monoxide in a home near a busy roadway. The heating system is sealed combustion and no gas appliances are used indoors. What is the most probable source of the elevated CO levels? A. Backdrafting from atmospheric combustion devices. B. Co-infiltration from attached garage via building envelope leaks. C. Emissions from building materials off-gassing under high RH. D. Faulty refrigerant circuit contaminating the air handler. Answer. Correct answer. B. Explanation. Coke infiltrate homes from attached garages, especially when the envelope is leaky and vehicles idle indoors. EPA and BPA health and safety standards warn that even short garage openings can raise indoor. Ompany is ruled out by sealed combustion. C. Produces VOx, not ompany. D. Is a misconception. Refrigerant leaks do not release ompany. Question 25. By evaluating performance data from various homes, Zheng observes that properties with hydronic radiant floor heating systems report higher occupant comfort at lower thermostat settings. What explains this phenomenon? A. Radiant systems eliminate thermal stratification. B. Airborne dust and allergens are reduced. C. Heat is distributed by air turbulence from low-speed fans. D. Water systems maintain higher supply temperatures. Answer. Correct answer. A. Explanation. Radiant systems warm occupants directly and reduce stratification, allowing for comfort at lower air temperatures. 2. Fordic less are supported by ASHRAE fundamentals. B is secondary benefit. C is relevant to forced air. D is inaccurate. Radiant systems often use low supply temps. Question 26. Across different scenarios, which solution most cost-effectively reduces energy loss due to attic bypasses in older homes? A. Increasing attic ventilation with additional ridge vents. B. Replacing blown insulation with closed-cell spray foam. C. Air sealing top plates, light fixtures, and penetrations. D. Installing radiant barrier on attic floor. Answer. Correct answer. C. Explanation. Attic bypasses, top plates, recessed lights, plumbing chases, key air leakage sites. Air sealing these before insulation is added is one of the most cost-effective strategies per an Energy Star retrofit guides that affects moisture, not energy. B is effective but costly. D affects radiant heat, not air loss. Question 27. The foundation of thermal envelope performance is minimizing conductive losses. During a retrofit, Mr. Menendez discovers exposed steel beams penetrating conditioned spaces. What should be done to reduce the thermal bridging impact? A. Apply surface-mounted electric radiant heaters to those zones. B. Wrap beams with continuous rigid insulation and air seal penetrations. C. Increase indoor air temperature to offset the cold surfaces. D. Add a vapor barrier over the steel to prevent condensation. Answer. Correct answer. B. Explanation. Wrapping conductive penetrations like steel with continuous insulation and sealing around them minimizes heat loss and condensation risk in line with IC and ASHRAE 90.1 envelope standards. A. Increases energy use. C. Doesn't address the cause. D. Doesn't prevent conductive losses or condensation alone. Question 20. The effectiveness of residential solar PV systems depends on local policies and design. Ortiz evaluates the homeowners at Oestum and finds minimal savings despite sunny conditions. What should she examine first? A. Inverter size relative to array output. B. Utility rate structure and net metering policy. C. Panel manufacturer warranty and degradation rates. D. Panel to roof mounting, height and racking material. Answer. Correct answer. B. Explanation. If savings are low despite sun exposure, utility billing structure is key without net metering or time of use alignment. Solar offset may not result in bill reduction. The DSIRE database and utility tariffs must be reviewed. A. May affect output but not billing policy. C. Relates to long-term performance. D. Is rarely significant. Question 29. Considering the evidence, Fontaine upgrades attic insulation and seals ductwork in a 1970s ranch home. Utility data shows reduced winter gas use but unchanged summer electric bills. What upgrade should be evaluated next to reduce cooling loads? A. Window shading and solar heat gain reduction. B. Installing a programmable thermostat. C. Replacing gas furnace with a heat pump. D. Increasing attic ventilation to remove trapped heat. Answer. Correct answer. A. Explanation. Summer loads are often driven by solar heat gain, particularly through glazing. Window shading, exterior or interior, significantly reduces this per ASHRAE 90.2 and Energy Star for homes. B helps only if occupant behavior is inefficient. C affects heating. D helps but is secondary to solar gain control. Question 30. To determine whether a ventilation system is properly balanced in a commercial space, Ahmed uses an anemometer at each grill and finds significant variation in flow. What is the next best step? A. Replace grills with higher throw models. B. Adjust dampers and rebalance supply return. C. Recalculate heating and cooling loads. D. Increase fan speed to improve total airflow. Answer. Correct answer. B. Explanation. Significant CFM aeration at grills points to improper balancing, which is corrected via damper adjustments. This is standard procedure in testing, adjusting, and balancing as outlined by NEB and AECA standards. They may help distribution but won't correct imbalance. C and D are broader interventions unrelated to airflow distribution.